You must have enjoyed your holidays. So we are meeting after a week. So let me quickly review what I discussed in the previous class and then continue from that point. Okay. So last topic was related with the cryptanalysis part, and we were discussing how to perform cryptanalysis of Wigner cipher. Okay, so to perform cryptanalysis, we have to do this in two parts, because in Wigner cipher we have an encrypted text, right? And we want plain text. Now in encrypted text, uh, if we want plain text, we need key, and that key we don't have. So what we have to do is we have to find that key. If we find the key, then we get the plain text. That is the goal. So how to find a key which is not a number, it is a sequence of numbers, or it is a word of some length. So first we have to guess correct length, and then we have to guess the correct key. So how to perform that? It is about that, right? So for that we have Kaspersky test that was discussed, right? And cryptanalysis, to perform cryptanalysis, we have to search repeated text segments, right? And that too of length 3, right? Because if we search repeated text of 3 characters, then we are omitting the possibilities of 2 characters such as double L, double E, right? Like that, right? So digraph, or we are removing the possibilities of digraph, but we are considering trigraph. So suppose there are 2 segments uh, that are found, and the distance concept was discussed. Distance is like first repeated segment appears, and then the same segment appears again. What is the difference between that, right? So if one segment is found repeatedly, then there is only one distance. But if there are several segments which are found repeatedly, right, then we have different distances, and in that case we have to take GCD of those distances divided by M is the key length which we are guessing. So M should be chosen such that D divides M. Okay, so that is the basic concept, and cryptanalysis uses the segments of at least 3 characters. That is the main thing which we have to take into consideration. Now, index of coincidence method is used to confirm the M value determined by the Kaspersky test. What is index of coincidence? Yes, I will explain you today with some example. In fact, I gave you one exercise to all of you to refer to that. Any of you have done that exercise? You have referred to the textbook example which I told you to refer? Any of you? Okay, today we will see that example. But main thing is that if you have the conceptual clarity, then the example would be much easier for you to understand. So today I will discuss that only. But I was highlighting this point that this question I asked in the examination, that what is the index of coincidence and what is the use of that. So some of you have written it correctly, although not exactly what is shown in this slide, but basic context of index of coincidence is written correctly. So that is fine. But this point that the index of coincidence method is used to confirm M value, which is determined by the Kasisky test, because you have to answer the question in the context of the discussion. It may have several other applications also, right? But many of you, I have found that you have not written this point, right? It is used to confirm the M value. What is M value? Key length. Okay. So this point was discussed, and we discussed that there are two uh, threshold values or two endpoints of values during within which we should get some particular value, and then we should try to reach to near to the standard English language take IC value. So IC value is 0.065, that is for English standard English language text. And if all letters are equally likely, then the IC value is 0.038. So it is if you have any random text, then it should be between these two, and then you should uh, choose the key so that the IC value is closer to 0.065. That is the main context, right? And that is what you are supposed to do in the example also. And I explain you theoretically how it can be done. And now we will see this with the example, with the help of example. Okay. So I suggest you to go through this lecture number 9. In case if you have not revisited, I have already discussed the theoretical concept of this cryptanalysis. Now we will see it with the example. Okay, these are the general steps what you need to follow. So let me first explain you these steps. So as I discussed that when we want to perform cryptanalysis of Vigenère cipher, we have to find mutual index of coincidence. So for two string X and Y ciphered using keys Ki and Kj, the value of mutual index of coincidence XY depends on the difference Ki minus Kj, mod 26. So what we are saying that we have one string X which is ciphered using Ki and another string Y which is ciphered using Kj. So MICXY depends on the difference between this Ki minus Kj. Okay. And a relative shift of S yields the same value as 26 minus S. So when Ki minus Kj is 0, that means if these two key difference, if we take the difference between these two keys, Ki and Kj, and if it is 0, then MICX XY is maximum and it is equal to 0.065. However, for other values, the estimate is comparatively less and it is ranges from 0.032 to 0.045 on an average. Okay, so this is what is going to happen when we have encrypted text. We have these other values, right? So ki minus kj will be some other value, and we should try to bring it to near to 0. So how to find the actual key? So in order to find the actual key, we divide the given string of encrypted characters into m rows, right? We have identified that the key length is m. So we divide it into, the whole text is divided into m rows. Okay. Now each row is a shift cipher, as we have seen in beginner cipher, that it is actually a shift cipher which has been shifted by key ki. So for each row, we find the mutual index of coincidence with respect to unencrypted English text. So we have two strings now. One is unencrypted English text and one is encrypted, and we try to find mutual index of coincidence, and we compute mi values by varying ki from 0 to 25. Okay, so for one key we will get the value closer to 0.065, and that is our correct key. Okay, and this process is repeated for m rows to obtain the entire key. Is the process understood? Then I will switch over to the example. Have you understood the process basically? Okay, doesn't matter. Let us discuss this example so that this process will be much clear to you. Okay, so this example was discussed earlier before the first session. She is listening, and our key word is Pascal. So what we used to do? We used to do the addition of pi plus ki, and that used to give us ciphertext. Okay, and we had seen that it is actually the shifting by these keywords. So for S, I, and N, all three are shifted by key value P, right? So that is the basic concept. And we have also seen this table. Those who attended the class in offline mode, you must be remembering that this table I had shown you. And even in online class also I had shown you this table. So this is actually a shifting, each row is shifted by one, right? So this we had seen. Now we are looking at the example of a beginner cipher cryptanalysis. Now you can see that this is example number 3.19 given in the textbook, the same example I am discussing. So let us assume that we have intercepted the following ciphertext, and this is the ciphertext. Now I will, as you understand that ciphertext cannot be pronounced by English language. So it appears to be some random character. Now if you look at this long string, this is having a large number of characters, like fourth row, up to 4 rows, it has characters. Now, this is our intercepted text. This is encrypted. And what we want to generate plain text from this encrypted text. Okay. So the Kaspersky test for repetition of 3 character segments yields in this table. Right now we have to apply Kaspersky test. Kaspersky test, what we have to find, that we have to find 3 character segment that is repeated. So we have to observe this text closely and then find all those characters which are 3 character segment, they are repeated, right? So in this table, you can see that JSU is the 3 character word which is repeated, right? So what is the first index at which JSU is found? So if you start counting from this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that. Then at the first index of 68, you will find JSU. If you see this, first index is JSU. Can you see this JSU word in this long string? Right. Now this JSU word first appeared at 68 index, and then again after 100 words, right? Again after 100 words, it appears. 100 characters, it appears. So we have to find the second index, that is here. If you see, can you see this second index? Right. So that is, if we have to manually count this. Okay, we have counted that first appeared here, that index is 68. Second time it appeared over here, that index is 168. So in this whole string, the first index and second index is 68 and 168. Now the difference between 168 and 68 is 100. Okay, so this difference, JSU difference, is found. Now, if you can recollect the theoretical explanation I gave you, that you may have different or multiple segments which are repeated. So here, so in that context, D1, D2, D3, if you remember, theoretically, we had seen that D1, D2, D3, if you can recollect this one, right? Okay. So it is that only. We are applying those concepts here. Now we find, so this is, the result is shown in the table. But when you are performing cryptanalysis, you have to actually find this in this encrypted text. So if you see the second segment, SUM, then SUM is also repeated. Now SUM first appeared at 69. Okay, can you see this SUM first index? Right, and the second index which appears is 117. So 69 and then 117. So here, see, it is here. Can you see this 117? Right. So we can count it here also, that SUM is 69, then 70, 71, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is 80, 81, 2, 3, 4, like that. So this is 107. You can do it, you can count this manually. So the difference between this 217 and 69 is 48. So we have found two different segments, and the difference between them is also different. Okay. Third segment that we find is VWV. So this is VWE, VWV. First time it appeared is at the index 72. So the first character index we have to count. So first index is VW 72 for VWV. Okay, and the second one is at this point, that is 132. Okay, you can do it manual count later on, but these two difference is again 60. Okay, fourth segment that we find is MPH. MPH is found at 119. This is MPH. Okay, and again it is found after, so this is 119, 20, 1, 2, 3, 4, 5, 6, and 27. 127, again MPH. Can you see this? Right. So the difference between these two is 127 minus 119, that is 8. So we have got different distances d1, d2, d3. Okay. So what we have to find is, I think text, this is same text. Okay. Now what we have to find is GCD. Okay. GCD, all of you do the calculation of the GCD for these four differences. Calculate GCD of 100, 48, 60 and 8. GCD of 100, 68. Okay, do this. 100, 48, 60 and 8. Can you do this and write the answer? Yes, Priyank, let others also try. You are answering. Urjit. Okay, others. Can others send the reply? You should find out GCD of these four numbers. So how will you find GCD of four numbers? Can you explain, Priyank, technique? Because we know the GCD of two numbers, but how to find GCD of four numbers? All numbers are multiple of 4. So that is correct. But which process you have followed? Yes, any other person, any other student who would like to reply? Factorization. Urjit, you use the method of factorization. So how you applied that for these four numbers? Others? Yes, other students. So Urjit's answer is very interesting. By factoring every number and choose the common factor from the list. Okay. So if you, I believe that since I had shown you the next slide, so the answer was visible to you. So it was comparatively easy for you to give the answer. But when it is not given, you have to actually find it, right? So Urjit's explanation is quite interesting, and that can be used. So you try to find out a factor that which is the factor through which each number can be multiplied and which is the greatest common, right? So it is greatest common divisor. So 25 into 4, 12 into 4, 15 into 4 and 2 into 4, right? So 4 appears to be the GCD. But otherwise, if you have to use the GCD method, then you can also uh, do some other methods of standard GCD calculation. So I hope that you will be able to do this, but I am only getting answer from 2 people. So I hope that others are also able to perform this. Okay. So now that GCD is what? GCD is our M. So M should be chosen such that D divides M, right? So 4 is GCD and that with the value of that, we can divide all these numbers. Now that becomes our key length. So what we have to do? We have to first try. Okay, we are first trying. So the GCD of differences is 4. So which means that the key length is multiple of 4. We don't know it is 4, but we can say that it is multiple of 4. Are you getting this? It is at least multiple of 4. That is what we are concluding. But we start with 4. Okay. So when we start with 4, which means that we should first divide the whole string. This is the whole string. Okay. This is the whole string, and that is divided into 4, m equal to 4. So 4 rows. So the whole string is written instead of one long text. The whole string is divided into 4 strings of length m. Okay, not of length m, of 4 in 4 rows. So we have encrypted text starting from L up to G, that you can see here, starting from L up to G, right? So total number of characters we have to count, and that we have to divide by 4. Okay, so here if you can see, this is L up to G, then I up to L. So here also you can see so where do you find? Okay, you have to actually perform manual count. First character is C1, second character is C2. Yes. So it is first character is C1. First character is C1 is cipher text. The whole text, encrypted text we are considering. Okay. This is second cipher text. Okay. This is third cipher text. And this is fourth cipher text. Okay. Right now what we are doing, we are dividing it with m equal to 4. First character, it is not first character, it is first line of encrypted text. This is second line of encrypted text. Okay, L C1, L in C1, I in C2. Okay. Okay, you are saying that we are arranging it in this way, LIOM. LIOM, right? That is because m equal to 4. So what happened here? Now, if you look at this, that if the key is repeated, we will have same cipher text, right? HXC, right? So for this key, we have several letters which repeats with the same character, right? So Priyank, you are right, and Urjit also have understood. I hope that others have also understood, so that LIOM, WGFE, WGFE, right? So the whole cipher text is encrypted with, see, you have to remember what is Wegener cipher. This is Wegener cipher. Okay. So what we do, Pascal is repeated. So here the key length is 6. So after 6, if there is any text, then we have to repeat it. So here what we have done in this particular example, we have found that it is a 4-letter key. We don't know key right now, but it is 4-letter key. So what we are doing, it is repeating. So LIOM, that is first ciphertext. So after that, again, the key is going to be repeated. So key is going to be repeated. So for W, it will have the same key as it is L. For G, it will have the same key, it is I. For F, it will be the same key as it is O. And for E, it is same key as it is M. And that is going to be repeated for each one of this character. So for all of these character, there will be the same key. Is that understood? Priyank and Urjit, I think, have understood. But what about others? Others, can you respond? Okay, very good. Dev, at least some students have turned on and replied. Hasti has also understood. Bhakti, very good, very good. Okay, so with m equal to 4, what we have to perform? We have to guess the key. What we have to do? We have to guess the key and find the correct table, right? So correct E. Now L, if you can now how this shifting is done? What is L? What is the value of L in A to Z table? In A to Z table, what is the equivalent value of L? 11. And what is the value of, if we start from 0, then L comes at 11. Yes, yes. And what is the value of I? 8. Okay, and O? 14. Okay, 11, 8, 14. And M? It is 12, right? Now what we want to find is that we want to find plain text from this ciphertext, and we know that if we can find correct plain text for this letter, the same key we can apply over here. So can you find out how this L to J conversion has taken place? So it is, what is the value of J? 9. And what is the value of L that we listed? 11. So how from 11 it has found the plain text of 9? Can you try? Because you already know the Wegener cipher. So the cryptanalyst knows that how the Wegener cipher is applied. So what is the method of decryption for Wegener cipher? For Wegener cipher, this is encryption. What is the decryption? Method of decryption? That was discussed in the class in when I discussed the C minus key mod n, right? So how, if key is known to us, how, which key was taken? So this Pascal example, encryption was discussed, and this is how we performed encryption, right? It is the same thing. So Pi equal to Ci minus Ki mod m mod 26, right? So Ci minus K mod 26. That is what we are supposed to use. Ci minus Ki mod m, I mod m. So m is key length, mod 26. So in this particular case, n value is 26. Okay. So how will you find this L to J? What method you will apply? Priyank, can you answer? Urjit? We know the value of C, that is 11, and we know n equal to 26. Okay. So here we guess that, let's say it is 2. So if we take 11 minus 2, then we get 9. Okay. Now, if we take 2, what will we get for W? W, what is the character value of W? 22 is the value, and if we take 2, we get U. Okay, so Urjit is correct. Now for G, what is the value of G? G is 6, and if we take 6 minus 2, we have 4, that is equivalent to 4. Okay. Now for I, 8, and what is the U value? 20, right? So now how will you find? U is the plain text. No, it is not going to be 2. It is not going to be, is it going to be 2? It is different. We want conversion of I to U. How it can be done? What will be the plus 12? So here a different shift. Remember that here key is a string. If you look at this Vigener cipher, this example Pascal, Pascal. So first value is 15, and that is repeated after every 6 character, right? So here in our case, m equal to 4. So the first value is 2. So after every 4th character, it will be 2. But this second character is different, right? So this second key value is different. Third key value is different. Fourth key value is different. And we have to take these different values. So what will be that in this particular case? For I, So plus 12 shift, I plus 12. And this is L minus 2. Minus 2 shift. And this is plus 12 shift. So how to perform this plus 12 shift? 12 is how to perform this plus 12? Are you getting? So we need to guess the key. Yes, because it is all about guessing, right? Yes, we are guessing the key. So we will see in this particular example, answer is shown. That is why we are performing this difference. But otherwise, what we have to do? We have to put this in row wise, and then we have to apply different key value and find the values from which we should be able to find some meaningful text. So here, if you see, have you understood the process, right? For C2 also, for I, we have to find U. So can anyone tell how I is converted into U? Minus 14. What are you saying, Nirav? I value is key is 14. How you are calculating, Dev? 8 minus 12. Okay. 8, Dev, what are you trying to say? 8 minus 12, 8 minus 20. You can speak if writing is a difficulty. You can use your mic. Okay, 8 minus 12 is wrong. Okay, Yash, would you like to explain this equation, how you have written this equation? Yash? Eight minus 14 is equals to minus 6. So minus 6 mod 26 is 20. So U is 20. Okay. So you have shifted it to 20 by applying this 8 minus 14. 8 is what? 8 is I and U is 20. So in order to get 20, we have to, because Ci minus Ki, so K value should be 14. So that Ci minus K mod 26 results into plain text later. Similarly for O, what is the value of O? Okay, note down these numbers, key numbers in your book, so that you can then identify the actual key. For O, what is the number for O? 14. And for L, if you want conversion of O to L, Ci minus Ki mod M mod 26. So how will you get 14 into 11? 3. Perfect, Priyank. Very good. So what happens? 14 minus 3 is 11. 11 mod 26 is 11. and we are converting O to L. Okay. Now from M, what is the value of M? 12. Okay. And for I? Key is 4, right? So I is 8. So key is 4, right? Now what is, now find the word which is represented by key. What is the key word of length 4? Key length is 4. Yes. But what is the correct. Others, have you found this key? Okay, 2 students have replied. Others? Urjit, yes, very good. So what it means is that you have to apply this guesswork, okay? And because you are doing cryptanalysis and you don't know the key, and key length is m equal to 4 that you have guessed. Now, because key length is found, now you will apply different values of key and try to find that whether this 4-letter key is representing any particular meaningful word. Like in this particular case, code is the keyword. Okay, like in the previous example, Pascal was the keyword. So here in this case, code is the keyword. So one possible method of guessing that our key is correct or not is to find that key is the key which you are guessing, it is a meaningful English word, right? So here, after applying different possible combinations, you may reach to conclusion that code is the correct key. So you can apply the same key for second column W, G, F, and E and see whether it is generating the same plain text. And after that, you try to see that it generating some meaningful statement. For example, in this case, if you combine this Juli, Julius. So first word Julius. If you see this Julius word, from receiver side they have not plain text, then how it guess key? Receiver side they don't have key, that is why they have to guess key. And they have, so it is not a simple task. So manually if you try to do it, it will be very time consuming. So you may write a program which may generate this possible key, right? You have to apply different possible values and then consider different combinations. So what we are discussing is a cryptanalysis, and cryptanalysis, the receiver doesn't have plain text. So this plain text which is generated, that is by applying the correct key, that is code. But if you know the length of key, then you may think what are the possible meaningful English word which you can find of length 4. That could be key and that you can apply. That is random value of plain text. What do you mean by random value of plain text? Plain text, when it is generated with some particular key, is random. It appears random, but when it is used in combination, then for correct key, it will give you the correct plain text. Are you getting this? Okay. So where IC and MIC is used. Okay, for that we will, okay, IC and MIC, we will see another example. Okay. So for that, I am showing you another example, and that is this example. Okay, now see this. Because this guesswork is very difficult, right? As this okay, is this screen visible to all of you? Browser example one, consider the plain text. Can you see this? Okay, okay. So I will not see your text messages because I am using this browser full screen mode, or maybe I can open this. I think I have the PDF of the same page. So I will use the same page so that I can communicate with you on text message. Okay, it is the same page, web page, which I have shown you. It is converted into PDF file. And this I had shown you in the before first sessional also. Now, as you found that it is very difficult, right? That how we, even if we know the key length, we will not be able to guess that it is the correct word. So what we have to do, let us see this example. Consider the plain text of Juarez quote discussed on the Kasiski method page, that is this. So what we have to do is the frequency count. Okay, the frequency count. So in this particular text, how many times A appears, B appears, C appears. Okay, is that understood? So this is the frequency count. Okay, and frequency count, this gives us, if we calculate the percentage times A appears, then 8.15, B appears 1.44 times. So that is the probability. So this is the English plain text, and if we compare it with the standard A, B, C frequency counts of English language, and if we find the index of coincidence, then it will be 0.038466. What is the meaning? The meaning is that IC is random. If IC is a random, then it is 0.038. But if it is English plain text, then it is 0.065. So in this particular example, where you are seeing, so we are applying this index of coincidence method for this particular text. And this particular text, if you read it, it is actually a sentence of English language. There are two ways of constructing a software design. Okay, constructing. So can you read the English text in this particular case? There are two ways of, right? So it is a complete English text, and you can read it in the hyperlink, where you will find this in the form of a sentence. So because it is a English plain text, if we do the mutual index of coincidence, then for plain text, for this particular text, it will be, so in this particular example, if by applying IC, we get 0.068. So we find IC, index of coincidence, for this particular text. Okay, by formula is same. Probability, we have found the probability, and then we take the summation. Probability here we have found. Are you getting? This is the probability. and then we take the summation and we take average, right? Summation of probability square. Okay, I equal to 1 to n equal to 26. So for all 26, we take the probability square, and what we get is this 0.0686. You have to do this manually. You can verify this by computation. Okay, it is not a straightforward. Here it is written in one step, but you have to do it manually. So now we take another example. Now this example is actually a different, right? So it is not a plain text. V, V, G, Q, G, Y. It is not a plain text. It is cipher text. So for this whole text, we have to find how many times A appears, B appears, like that, the same method. And then we have to calculate the probability, and then we find the index of coincidence, and that is 0.041. 0.041 is closer to 0.038, which makes this text random. So we can say that, okay, we have calculated IC value for this, and that appears to be the random text. Okay, now if we consider third example, so in a third example, here for this particular encrypted text, if we calculate A's, B's, and up to Z, and if we take the probability, then the probability results into 0.66332. Right? Now this is the same result as it is found in example 1. It means that this English plain text has index of coincidence, and this encrypted text has index of coincidence, which is same. That means these two texts are actually same, but they are only shifted in Ki, Kj. So that is mutual index of coincidence. So if we shift this, so if the Ki minus Kj is 0, then we have found that the plain text and cipher text are same, right, or closer to 0. So from that we can find the key. Is that understood, the method? Yes, Priyank, have you understood now where we have applied index of coincidence and mutual index of coincidence? Okay, in brief, I am once again repeating, and I will give you this hyperlink to refer, right? This is the plain text. For any given text, we have to count the frequency of each character, and this frequency of each character will give us the probability. Percentage is probability, and that probability square is our index of coincidence. Now this index of coincidence that we found, we compare it with the English text, and if it is closer to English text, this is known. Okay, this is known, 0.068. This is known, and here we have 0.066. Okay, now what we happen, and find the IC of plain text, and is that is near to 0.6, then the key is correct, right? Yes. So if we find that the plain no, we have to guess key, then we have to find IC method, and if it is matches with, see, already what you have here in this particular example, you have here you have what is available with you, cipher text. So here you can calculate IC, then you apply key, then you get the plain text, and then again you calculate IC, and if it is matches, that means you have found the correct key. Priyank, have you understood? Are you saying the same thing? Okay. See, once again, I am repeating, all of you understand, this is the ciphertext. We calculate IC of this. Okay. It will be some value because this is fixed which we have. Now what we do, we guess the key, we convert it into plain text, and again we find IC. And if these two IC are closer to each other, they are same, that means we have found the key. Understood? Ciphertext is random. So IC is, but ciphertext is random. But here in this example, you see that for plain text, for first example, this is not a random text. Okay, but its IC value is 0.06632. Now, if we apply Wegener cipher and convert it into ciphertext, and if we find its IC value, then it is same. And that is why for plain text and ciphertext, the IC value should be equal. That is the observation which we know. That is the theory which I discussed. Is that clear to all of you? Okay, so this is what I am sharing you today, and I leave this part as a exercise, and I want you to study this. Do it manually. It is not a simple task. It has to be done. But first, if the understanding of the process is clear, you will be able to do it. Okay. All right, so I'll stop here for today, and you will have to do some exercise on your own based on these context, concepts and examples which I explained to you. Then only you will be able to understand it. So I suggest you to pay attention to this, all these things, and complete this homework of understanding. If any doubt is there, you can ask me again. Okay, so I stop here for today, and I hope that many of you must have got the idea of how we can perform crypt analysis of Wegener cipher. All right, so I stop here